In this short video, we review populations and samples and how we use statistics, characteristics of our sample, to estimate parameters, characteristics of the population that we don't know. Previously, we've used the mean and the standard deviation to describe how large or extreme an individual score is relative to the larger population. The mean tells us what to expect, and the standard deviation was that yardstick to measure how large or small our result is, whether we're talking about a score on a test or the weight of a rhinoceros. Statistical inference uses the same general principles, but now we're not just describing an individual result. Now we want to draw conclusions about a whole population. We want to infer or estimate characteristics of a population based on what we see in our smaller sample that we've taken from that population. As part of this, we're going to be switching our focus from individual scores to sample means. In a way, it's like we're treating that sample as an individual case from the population. So rather than ask questions like, how high did Theo score on the math test? Inferential statistics ask questions such as, do students who receive the new math curriculum score higher on the math test than those using the old curriculum? We'll do that by looking at the class mean rather than Theo's individual score. Now, to help clarify this change in our focus, let's talk about a few key points. First is the population. The population is that larger universe of individuals about which we want to make a conclusion. It's everyone we want to understand or describe or make assumptions about in our study. Generally, we think about the population as a real thing. It might be all the public high school students in the state or all the registered voters in a country. But sometimes a population may be a little more theoretical, a little more abstract, such as all the possible outcomes that might occur or all the people who might receive an intervention. The key is that the population is everyone. It's everything about which we want to make a conclusion or inferences. In contrast to the population, the sample is a subset of the population that we use to estimate characteristics or features of that larger population. In reality, we're rarely in a position where we can collect data from the entire population. So instead, we use a sample from the population to estimate what that larger population actually looks like. The sample needs to be similar to the population, ideally randomly sampling from the population as a way of helping to ensure that it's as representative as possible. Now, all of that's discussed elsewhere in other videos. But the key is that the sample is part of that population. It's the group we use in our study, and we're going to use the data from the sample to estimate what the population looks like. Or if we're testing an intervention, we test the intervention using our sample as a way of estimating what the effect might be if we could apply the intervention across the entire population. Now, because our sample won't be exactly the same as the population, we know the results are going to be off a bit, hopefully only slightly. But we'll also see how we can use inferential statistics as a way of estimating how close the results based on our sample would be to what we would really see if we could collect data from the entire population. And that's pretty neat. Because characteristics of samples are used to estimate characteristics of the population, it can get a little confusing at times. For example, are we talking about a mean for the sample or the mean of the population? This table summarizes a few key features of samples and populations and how they're represented in research writings. The features and characteristics of the population are called parameters, and the corresponding features and characteristics of the sample are called statistics. We know the statistics because we can calculate them based on our sample. We use the statistics to estimate the parameters in the population. For example, in previous videos, we saw that we used mu to indicate the population average, a parameter, and x bar to indicate the sample average, our sample statistic. Similarly, sigma is used to indicate the standard deviation in the population, while S is used to indicate the standard deviation that we calculate from our sample. Now, if you look closely, you'll notice that this is a lowercase s, but we've been using an uppercase S for the sample standard deviation. So what's going on? Now, this is no typo. We use an uppercase S when we're talking about the descriptive statistics version of the standard deviation and the variance, when we're only describing our sample. But things change a bit when we want to calculate inferential statistics and use the sample to estimate what the population looks like, what that population standard deviation and variance are. Now, as we'll see in later videos, the formula changes slightly when we do this, and so we use a lowercase s to make it clear which standard deviation formula we're talking about. An uppercase S means that we're talking about the descriptive statistics version, just describing our sample. The lowercase s means that we're talking about our estimate of what the population standard deviation and variance are based on our sample. Okay? Now, in practice, we almost always use the lowercase s, not the uppercase S that we have been using so far. And that's because the whole reason we're doing the study in the first place is typically to estimate what the population looks like. Our focus typically is on the inferential statistics. Now, again, we'll get to how the formula slightly changes in future videos. Okay? Continuing with the symbols for different parameters and statistics, the sigma squared is the variance in the population, which we estimate with the variance in our sample, that lowercase s squared. Now, the same principle applies to other characteristics of populations and samples. For example, the correlation coefficient between two variables in the population is represented by the Greek letter rho, while the correlation between those variables in the sample is represented by r. The key point here is that we're using the sample statistics to estimate the population parameters. In particular, we must use the inferential statistics version of the standard deviation and variance, lowercase s and lowercase s squared, to estimate the population standard deviation and variance, sigma and sigma squared. Okay, this wraps up our review contrasting populations and samples. All right, take care.